This module is going to be about JSON in SQL Server. So what is JSON? Stands for JavaScript Object Notation, and it's a way to exchange data between different applications or websites. It's lightweight. It's easy for machines to parse and to generate. It doesn't really matter if you're on a Mac or a PC or a cell phone, because there's a way to understand and to parse JSON. JSON is a text format, it's language independent, and it is an object notation such that data is in name pair values, it is separated by commas, curly braces hold objects, and the square brackets hold arrays. So we think of JSON as an alternative to data in an XML format or in a comma separated value file. There have been attempts to have different ways to exchange data, and JSON is one of those. JSON can be stored in a special purpose database like MongoDB or in a general purpose database like SQL Server. Now, JSON does not have a native data type. So we normally take n varchar max and put our JSON into it, and then we're able to apply methods to it or to query it. And again, JSON is frequently used to transmit data within applications or between applications to web services and network sources. Here is some data in JSON format. So here's the ticker symbol Apple. Company name's Apple Incorporated, the industry's tech. Here is Advantage Oil or AAV, Advantage Oil and Gas Limited, industry is oil and gas. AMAT, Applied Materials, and its tech. So that's what information will look like in JSON. You see the square brackets. Each individual row is mapped to curly braces or an object. Here is the same exact data in a table format, but it's much easier to transmit that JSON than it would be to do it in a table. Now, in SQL Server, there are several native built-in functions that enable NoSQL and relational database concepts to be in the same database. Relational columns can be combined with columns that contain documents that are formatted as JSON. We can also parse and import JSON documents into SQL Server database tables, which we will show later in the video. Here are some common SQL Server JSON functions. Is JSON, returns a 0 if it is not, and a 1 if it is valid JSON. JSON value will take a scalar or a single value from a JSON string. JSON query extracts an object or array from a JSON string, and it's much like other types of query mechanisms that we're used to. JSON modify performs an update on the value in a JSON string. Here are some common JSON operators that we use in a select from where query. For JSON is going to help format our output to be JSON. For JSON Auto, it's the same thing. We're going to output to JSON, but it's going to be determined automatically based on the number of columns that are listed in our select statement. JSON path gives us far more control, and it's also more complicated as you export your JSON output. Now, JSON can be very hierarchical. You could have very much nested levels. So if I had 3 or 4 tables that I join in a regular SQL and I looked at it and it's really hierarchical, you can represent those same hierarchies in JSON as you nest those. We'll show an example of using bulk column and open row set to import JSON data and import it into a SQL Server base table. Here is a pretty standard SQL query But at the very end, we have for JSON Auto. So we're doing an aggregate and a group by. We're going to group by ticker symbol, get the average volume just for those times where it was a trade date on a Friday. This is the output in a little bit nicer format from that query. So it gives us the average volume for each ticker symbol. So here's that same query in SQL Server. We will execute it, and we have put our results to grids because it is much easier to see and to demonstrate here than if you have your results going to text. I click on the data in the grid, and it will open up another window, and it will scroll to the right seemingly forever, giving us each of the JSON objects here for the average volume for each ticker symbol. Here is a join as we're going to output to JSON Auto. So we have a join from calendar to stock data, and so we're going to see a little bit different output. Here is the output of a JSON join, and it looks really small right now, and it's because I wanted to show the entire row in the answer. So here's the ticker symbol, the open, the close, and then the calendar data is listed next. So let's zoom here, and we'll see this calendar data. And we note that that's nested here, and we're showing the actual date and the fact that it's a holiday here. So we have our own brackets here on this JSON output. So here is our JSON join query in SQL Server. We will execute it, click on the grid, and we'll see the answer here. As I scroll across, we'll see now here that we have the data from the calendar table. And so it was aliased to be a C. Here's the actual date, and here's the specific value for the date and the day type being holiday. Here is the same JSON join. The only difference is we've added this root and we're calling it holidays. And here's the output. Notice this is where the root is, and that's holidays. So let's zoom on that just a little bit. Maybe just zoom it a little more, and we can see that we have a root, and that's called holidays, and that's going to be important in some of the queries. So if we execute the query and click on the grid, we see that here's the root that we had in our query, and we put that with a for JSON path and included a root. The next operation will show how to move JSON objects into SQL Server as relational rows. So we declare a JSON variable. It could have said anything, but we put @JSON and we put varchar max. Then we set that equal to, and what we're going to do is find a file with the JSON data in it. So we use bulk column, and then we use open row set, and we identify where the Apple JSON file is. And so now that is going to be the variable @JSON, after which we will insert it into the database, stock data, and we will use open JSON method here on our variable, and we're mapping each of these columns in our JSON file. It's not a column, but each of the attributes, and we're mapping those back to the columns in SQL Server. So here are the 4 days of data in JSON format for Apple, and that's what we're going to import here in just a moment. So we again declared the variable, we copied this over, and we'll execute, and here it says here at the bottom that 4 rows were inserted. So that means we were successful in getting our data inserted. We do a select star from stock data and look for those 4 rows that have been inserted. We click X, and indeed those were imported. We didn't have a ticker symbol or an industry because those weren't part of our JSON, but we do see all the data that we imported for Apple in tech. We see all the pricing data. The next query will be how to convert JSON in its object into tabular data that we would normally affiliate with relational databases. So here we declare a variable at JSON of type string, and it's going to be n varchar max. And here's all the data. N is the encoding scheme, and we have a root tag of stocks, and then we have our JSON data is date, open, high, low, close, and volume. We have 4 dates or 4 nodes of data. So we've set our at JSON equal to all of this JSON data. Now here is the query that's going to convert it into columns and rows. Select star, and here we use open JSON, and we pass it our at JSON string. Remember, at JSON string was declared here, so we have at JSON string, and the root is stocks. We use a CTE, that is the with statement, and we have date, open, high, low, close. We define the data type, and the $signs means root, so it's at the root, and then it's date, root, open, and so forth. So if we select star from OpenJSON and then define the table in a CTE, this will be our results. The date, open, high, low, close, and volume for these 4 rows. So here is this query in SQL Server. Again, notice that we've declared a variable of type n varchar max and set it equal to the data for those 4 days. Now we have root here called stocks, and we have each of the pieces of data. And down here we have the query that's going to transform it from JSON into SQL. So I click execute and scroll up the answer, and here you see those 4 days now appear as regular table format in SQL Server. The next thing we want to do is add a new column and put data from the other columns into the new column and have that data be in JSON format. So here we add a new column that's going to be called all data, and it's a very large string variable n varchar max. That's where we're going to stuff all our JSON. The next thing we do is create a common table expression with the with clause. The name of that expression is Babe Ruth. It's going to have 2 columns in this common table expression. It will be ticker symbol and a lot of JSON. So this inner query then is a correlated subquery. I'm joining this outer table of company information to an inner copy of the table of company information, so that when I'm looking at a ticker symbol here, it's looking at the same ticker symbol in here. So I say which columns are going to be in my JSON. I do the join. I do for JSON path, so that will create my output in a nice format. Then I have to use the option without array wrapper so that it's going to work as JSON and it won't have those square brackets. Once I've made my CTE, then I do the update statement. I update the company information table. I set the all data column equal to the column called my JSON. That's what this column was called in our CTE. So I set all data equal to my JSON, and then I join the company information table to the Babe Ruth common table expression. Once I do that, I'll check to see that it looks like valid JSON right here. Let's go ahead and do that query here in SQL Server. Again, we're going to add this column, and it's going to be a character data type. And then here's our CTE that creates our two columns, which we use in our update statement to put JSON in its own new column. We execute, and let's look at the data here at the bottom. It's exactly what I thought it would look like, and that is a ticker symbol, and we have city, state, country, and we can see that as we move across. So we can see that we have two columns that we listed, although all are in the table, but we have a ticker symbol and we have a JSON column. Here is an alternative to the previous method, and it's completely different. I find it very instructive for students to see sometimes two different ways to do the same exact thing. Here I add the new column. This time I'm going to declare a variable. I call it @JSON, and it's going to be the nvarchar max again for a very large string. I set that variable equal to, and that's the results of a query using JSON path. So I take the results of that entire query, stuff it into my variable. Now I'm going to use that in my update statement. So I update company information, set company information, all data column equal to something I'm going to generate in a CTE and a subquery. The basis of this entire subquery is that @JSON variable, which holds all the data that I'm going to use to determine my query. So this is a very alternative method. We have to know things like this $sign represents the root, and we need to know the ticker symbol is lined up here in the JSON part of the output. So that's a second way to do it. Here is that second method where we declare a variable that's going to be a large string. We call it @JSON, and then we stuff the results of this query into our variable. Again, we update the company information table to populate that new column that we called all data. Let's go ahead and execute this query. And let's pull the results up here so we can see it. And we can see that, again, we have our ticker symbol, and then we have a lot of JSON here that's in that new column. Now that we have a JSON column, wouldn't it be cool to write a query on it? In fact, here's a query that looks at JSON columns as well as relational columns. So here we have ticker symbol, company name, and that is coming from the columns that are in a relational format. However, city, state, and zip code are in the JSON data. So we take the JSON value method, we're referencing the all data column, here's the root, and we say we want city, JSON value all data state, JSON value all data zip code. The isJSON is going to return a 0 if it's not JSON and a 1 if it is. And so I named those columns isItJSON. Also, I have put a condition in the where clause that says if the JSON value in all data of state have it not equal to California. So we're going to exclude California based companies. Here's the answer. You see ticker symbol, company name, city, state, zip, is it JSON, is it JSON? So the output all looks like relational columns, but we pulled some of our data from relational columns and other parts of the data we pulled from the JSON column. Here's that query in SQL Server. If I choose to execute it and pull the answer up, you can see that it gave me a ticker symbol, company name, city, state, zip, is it JSON, is it JSON? Quite obviously, the all data column is JSON, whereas the industry column is not JSON. So that's basic querying in SQL Server for both relational and JSON columns. Now we can query the JSON column. We will look at JSON query and JSON value. So JSON query works best when there's an array or multiple values. And JSON value returns a scalar value. So I did a query here that does a little bit of both. I did JSON query all data, so I'm seeing all of the JSON from that column. And I also did it with a $sign to represent the same thing. And this time JSON value, all data, and city, because it's only going to return a single value. So JSON query works better if somehow there's a multi-valued attribute, or if you've done a join and again there are multiple values. Here is the results of that query. Here's the first one that just says result, then JSON query, then city. These two are the same exact results. Here is our query, and we can just go ahead and run it. And we can scroll this, and we see that this is the result column, the JSON query column. We've named it and city. And again, JSON value can pull out the single city here. In conclusion, we have noted that JSON can be used to store and transmit data from applications and websites to other applications and websites. Relational data in a SQL Server table can be exported in a JSON format. JSON data can be imported into SQL Server, and it can be shredded into the columns in a table. JSON data can be displayed as relational tabular data in SQL Server. It can be a string data type, and it can house JSON data. Also, JSON columns can be queried using special JSON query functions. Relational tabular data can also be queried alongside JSON data. A future video will have the topic of creating schemas in a JSON document, and we can create those from relational schemas. So I really like JSON data, and in my opinion, JSON rocks like Van Halen.